Let us introduce you to Q equals mc delta T. This formula on thermodynamics is used to calculate if the system is negative or positive. An exothermic reaction is negative since it releases heat. An endothermic reaction is positive since it absorbs heat. Q. This is the quantity of heat energy that is released or absorbed. It is measured in joules. M. This is the mass of the substance. It is expressed in grams. C. Specific heat capacity of a substance, expressed in joules per gram degrees Celsius. Delta T. To find delta T, you must do the final temperature subtracted by the initial temperature. This is in degrees Celsius. Here's an example to solve for Q. How much energy is required to raise the temperature of 55 milliliters of water from 25 degrees Celsius to 28.6 degrees Celsius? M. Since 1 milliliter of water is equal to 1 gram, the M is 55 grams. Remember that other substances have different densities, therefore read the question carefully. C. The specific heat capacity of water is 4.19 joules per gram degrees Celsius. Again, this will vary according to the substance. Delta T. Temperature final, 28.6 degrees Celsius, minus the temperature initial, 25 degrees Celsius, gives you 3.6 degrees Celsius. Many make mistakes by subtracting the opposite. Equals mc delta T. 55 multiplied by 4.19 multiplied by 3.6 gives you 829.62 joules. There's two significant figures, therefore the answer is 830 joules, thus resulting in an endothermic reaction. Note, if the answer is a big number, simply divide by 1000 to get kilojoules. If you need to find a missing value, such as mc or delta T, work backwards by using reverse BEDMAS to solve for the missing variable. To find the molar heat of reaction, you first need to find the Q of the system. If the Q is not directly given, then you solve for it by using the thermodynamics formula. After the Q, you divide it by the number of moles, which depends on the question. If the moles are not given, but the grams are, it requires a simple division. Remember that it is in kilojoules per mole.
Here's an example to find the molar heat of reaction of 48 grams of oxygen gas. To do this, you first need to take your energy of 830 joules and divide that by 1000. This gives you 0.83 kilojoules. You are now able to calculate for the molar heat of reaction. We now know that 1 mole of oxygen gas is equal to 16 grams. So how many moles is equal to 48? Simple cross multiplication will give you 1.5 moles. So now that you have your energy of 0.83 kilojoules and your moles of 1.5 oxygen gas, you are ready to calculate for your molar heat of reaction. To solve for your molar heat of reaction, you need to take your 0.83 kilojoules of energy and divide that by your 1.5 moles of oxygen gas. This should give you 0.55 kilojoules per mole. This means that 1 mole of oxygen gas is equal to 0.55 kilojoules. Thank you so much for watching.